Welcome to the structure of Unity. In order to make games, you have to understand the main parts of Unity, the logic behind them, and how they work together. This is an extreme explaining tutorial. A game consists of one or more scenes. Each scene contains a number of game objects. Using an analogy, you can see game objects in a scene much like actors or props in a scene of a theater play. Aside, the reason Unity uses scenes is that only one scene is present in the primary memory at a time. When Unity changes scenes, it purges all game objects belonging to the old scene from the memory and loads in all game objects from the new scene. Each game object consists of a number of components. So using another analogy, you can see a game object much like a car that needs to be assembled with help of components. Components like car body, motor, wheel, etc. Each component will have a number of properties. In the car analogy, a motor component would have properties like number of horsepowers, number of cylinders, and so on. In Unity, you will not work with a picture like the one you see on the screen. You will instead see it in a form of the Unity editor that contains a number of windows. Scenes reside in the project window, typically in a folder called Scenes. Here we have two scenes called Main Scene and Start Scene. Aside, in the project window you will find all kinds of files, sound files, graphic files, text files, code files, and many other kinds of files. You can actually find these files in the Finder if you're using Mac or Windows Explorer if you're using Windows. The files are typically grouped in folders. A scene folder that contains our scenes, a scripts folder that contains our scripts, a sprites folder that contains our graphics, and so on. You will find the name of the current scene at the top of the hierarchy window. In our case, it is the main scene. Under that name you will find all the game objects that belong to that scene. Here we have game objects like main camera, background, and so on. Aside, while the project window contains files that are stored in the secondary memory, typically the hard disk, the contents of the hierarchy window shows what is loaded in the primary memory. By selecting one game object in the hierarchy, we can see its components in the inspector window. Here we have selected the player pedal, and we see that it has components like transform, sprite renderer, box collider 2D, rigid body 2D, and the script. And if that is not enough, we can click on the Add Component button and add additional components. Each component has a number of properties. By clicking on the little disclosure triangle next to a component, we can see its properties. Here we have opened the transform component, and we can see that it has properties like position, rotation, and scale. Another component that is also open is the rigid body 2D, where we can see properties like body type, material, and so on. Let's now take a closer look at the components. As we have said, you can attach components to your game objects. There are hundreds of different components to choose from. The components are collected in groups. Here I have selected the Physics 2D group, in which you can find components like Box Collider 2D, Edge Collider, Fixed Joint 2D, Platform Effector 2D, and others. Another component that a game object can have is a script. A script is a special type of component. It allows you to specify custom properties. For instance, in a bird script I have defined a public float called speed. And as you can see, it shows up as a property in the inspector. I can define as many such components as I like, and they can be of different types, even lists. Scripts are powerful. They can access other components via the getComponent generic, as you can see an example of here. Having that reference, the script can alter the properties of that component. For instance, here, the gravity scale property is changed. Scripts can even manipulate other game objects and their components. With scripts comes great power. Game objects are the power horses of Unity games. But apart from having components, game objects can also have other game objects as their children. And those children can have their own children and so on. The power of having children comes from the fact that however you move, rotate or scale a parent, the same transformation applies to all the children. For instance, look at the musician game object that has a flute as a child game object. If you move or scale the musician, the flute will be moved and scaled as well. Game objects can be created dynamically. Typically, you will have a spawner game object that will spawn game objects while the game is running. You see an example up here. This pipe spawner object has a reference to a prefab called pipe. In the script, you will have an instantiate statement that will instruct Unity to dynamically create the pipe. Observe that when the object is created dynamically during the game, it will appear in the hierarchy, where it will have the name of the prefab followed by the word clone in parentheses. Let's summarize. A game consists of one or more scenes. Each scene contains a number of game objects. Each game object consists of a number of components, like transform, sprite renderer, script, and so on. Each component will have a number of properties that can be manipulated manually or via scripts. Game objects can have other game objects as children. Game objects can be dynamically created during the runtime using prefabs. Script components are where the real power lies. A script can add custom properties to your game object. A script can access and manipulate components of any game object in your scene. The script can call thousands of built-in library functions in Unity. You can find those functions in Unity documentation, but that is a topic for another tutorial. The scripts are written in C# programming language, and to harness its power, you need to learn C#, but that is also a topic for another tutorial. We are finished with this tutorial. See you in another tutorial. Thank you for watching.